Black holes aren't what you think they are. They're not holes, they're not black, and we can actually see them. And we've even managed to take a picture of one. You are currently looking at something incredible. The first ever image of a black hole, the one at the center of the Messier 87 galaxy, 55 million light years away. Now we know there's a black hole at the center of our galaxy, the Milky Way, which is 27,000 light years from the solar system. And we know that it's super massive because in 2008, Professor Andrea Getz and her team measured how big it was and found that it was 4 million times more massive than the sun. This measurement was such a big deal that in 2020, she won the Nobel Prize in Physics. To work this out, they studied the orbits of the stars moving at incredible speeds around the black hole and used this to weigh the black hole.
If there's a black hole at the center of our galaxy, that's going to force these objects that are really close to the black hole to move much faster than they would move if there were no black hole. So the first thing you want to see is that there are very fast-moving objects where you think the black hole is. If there's a black hole, there's a further prediction you can make about what these stars are going to do. They're going to move around the black hole on very short periods. In other words, you're going to be able to see them move on more than just straight lines. As part of their travel around the black hole, these stars are going to move around the black hole because of the gravity, just like planets move around the sun.
Contrary to their name and to common belief, not all black holes are black. In fact, the gas and dust that spirals around the black hole can be accelerated to huge speeds, which heats up due to friction, causing it to glow. In fact, feeding black holes are some of the brightest objects in the entire universe. There's a supermassive black hole in the center of every galaxy. So how do we know? When quasars were first discovered, they were thought to be hugely bright stars, and any ideas of them being black holes were dismissed as just crazy. But we now know they are feeding black holes. Now they're described as feeding because stars and gas clouds that get too close are torn apart violently by the immense gravity and then lost beyond the event horizon to become part of the black hole. They're essentially like a little snack for the black hole. There's a quasar at the center of the Cygnus A galaxy that's 1 trillion times brighter than our sun. And Dr. Andy Fabian from the University of Cambridge is studying this quasar with X-ray images. These help reveal the gas clouds that are orbiting around the black hole.
There's a lot of other things going on out there, and enormous amounts of energy being released, which we can only be aware of if we look with X-ray eyes. We could see what was going on at the center, and we could start to understand how the black hole was feeding energy out into all the surrounding gas.
The friction generated by this dense atmosphere of gases produces the hottest and most electrically charged environment in the universe.
What we know is that the hotter something gets, the brighter it gets, the more light it emits.
By feeding on all this gas, the black holes sometimes end up with just too much material around them and end up burping out a load of it, which then impacts the galaxy. This can actually expel a load of the gas that the galaxy would have used to make more stars, essentially stopping the galaxy from growing any bigger. So black holes seem to wield a worrying amount of power. They can literally control how big a galaxy can grow.
Galaxies could, in a way, be much bigger than they currently are. Something is stopping them growing larger, and that something is the black hole at the center. Now, this is bizarre because the ratio of the size of the black hole to the size of the galaxy is the same as the ratio between a grape, something this big, and the size of the Earth.
It sounds impossible that something that small would have so much control over something that big, but that is what's going on. It's been calculated that the mass of a black hole is on average about 0.5% of the mass of a galaxy. Essentially, the bigger the galaxy, the bigger the black hole will be. This correlation made astronomers start to wonder whether black holes might have been present or even responsible for the birth of their galaxy.
Because it really meant that there was something linking these tiny supermassive black holes in the center of galaxies with the whole galaxy itself. It meant that somehow their whole history had been intertwined, that the growth of the galaxies and the growth of the black holes was somehow related.
Now, in the early universe, we don't know if stars formed first or if black holes formed first. But if the black hole formed first, then the galaxy of stars could have then formed out of the gas that was swirling around it. What everyone really wants to know, though, is what happens when a star gets swallowed by a black hole. Well, a couple of years ago, a gas cloud called G2 came perilously close to the event horizon of the black hole at the center of our galaxy, the Milky Way.
This is the first time, really in human history, that we have not only known an event like this was going to happen, but that we are prepared with the right sort of technology to see the details unfold.
Astronomers monitoring the event were able to test the effects of the black hole on this gas cloud. It was essentially on a collision course with one of the most powerful entities in the entire universe, and it was being stretched out on its way there.
It was moving quite fast, and it's not moving in a straight line, but it's a curved line. And that's a very, very bad sign, because it tells you, well, there's something acting on it. It tells you, wow, gravity is pulling on that object.
Instead, though, it was spaghettified, and it circulated the black hole and then was essentially catapulted back out into space. Lucky escape for the gas cloud. This event confirmed that it is possible to get perilously close to a black hole and still escape. So, there's a black hole at the center of every galaxy, and they have the power to dominate everything around them. But they're not just giant hoovers sucking everything up around them. Stars, gas, dust, they're all happy to orbit them with no issues.
We're seeing the black hole at the center having a galaxy-wide effect on the surroundings.
So if they really do have a galaxy-wide stronghold, and the one at the center of the Milky Way has been there since its existence, that means that you, me, and all the stars that we can see have always, and are currently right now, orbiting a supermassive black hole.